Oh, somewhere over the rainbow, way up high, the dreams that you dream of once in my love goodbye. Over the rainbow. So there's your music intro for today. Chose some Hawaiian music. I love going to Hawaii when I have the chance, opportunity. So that was Is with that Somewhere Over the Rainbow. So hopefully your day has been going well, or your week's been going well whenever you've seen this video. I'm not sure how long it's been since you've been sheltered in place, but I'm ready to give you the 5.3 lecture. So here we go. Let me share my screen. So just like before, I'm going to be working out problems on the packet pages. And we'll just go for it. This is something for you to work on. Follow along. So the last time we looked at a section, which was 5.2, it was on sum difference formulas, or identities sometimes. Remember, instead of formulas, sometimes we call them identities. We have some in this section. One's called double angle, which is when I'm going to look at these first. And these will help you sometimes when you possibly have, for instance, an angle that's not on the wheel, like the sum difference. 15 degrees wasn't on the wheel. So we were able to use that formula to come up with the exact answer. In like manner, these might be helpful as well. And so double angle, that means 2 times the angle. Look at cosine has 3 versions. So you can pick any one of these that you like to use. And tangent has 1. So for instance, these guys right here, we're going to end up giving you sine theta is 5/13. They're going to ask for sine of 2 theta. That does not mean you double this answer. Not at all. Does not mean that. So the process is the following. You're going to draw your picture. That'll be the big thing. Theta lies in quadrant 2. So if I do this, and then I end up having my quadrant 2s over here. So let's say I have my angle like this, and this would be theta. Make that a little bit further out. Drop the perpendicular to the x-axis. And then based on sine theta is equal to, what is it, opposite over hypotenuse. Or you could say it's y over r. Here's my y. So this would have to be, y is 5, and it's positive because it's above the x-axis. And r, right here, r is 13. And your job is to try to find, in this case, the side of the triangle that's on the x-axis. And if you use a Pythagorean theorem, you're going to find out it's 12, but you want to pick negative because it's to the left of the origin. So we've got a triangle with thetas. I want to be able to get a result for this when I use, and the identity we're going to use is this one here. So that's 2 sine theta cosine theta. So that's multiplication here as well as there. So 2 times. This part right here, you already know. That right there, you already know. That's given to you in the top of the problem right here. Sine of theta is 5/13. This right here is 5/13. And of course, you bring down the multiplication, and now you need cosine. Well, cosine wasn't given to you, but you can certainly figure cosine out based on the triangle with theta. And cosine is adjacent over hypotenuse, so negative 12 over 13. So that's times negative 12 over 13. And so based on the formula, multiply straight across, you get, it looks like negative 120 over, what, 13 times 13, 169? There's no way of checking this. You can't put just that in your calculator all by itself. You have to trust the formula works. The next one, we need to use the formula for tan 2 theta. So that would be 2 tan theta over 1 subtract tan squared theta. Now remember, tan squared theta is the same thing as tan theta squared. We talked about that prior to spring break. And we go back to the triangle that you set up, or I set up. And this would be 2 times, remember this is a fraction. Okay, tan theta. Opposite over adjacent, y over x. So that would be 5 over negative 12. And then 1 subtract bracket squared. Again, you're going to put 5 over negative 12. That's negative 12. Hold on one second, please. Well, I got the washing machine going and I can't turn it off right now. So in a second, I'm going to pause it. Give me a second. Let's see. Okay, got that under control. Back to screen sharing. Try this again. Okay, back to here. Okay, we're going to multiply straight across. That'd be 10 over negative 12 divided by, that's negative. And that's 1 subtract, okay, squaring both of these, I get a 25 over 144. And then we get negative 10 over 12 divided by, sorry, page 71's in the way. Make that go away. Common denominator here, 144. So 144 over 144. I'm going to run out of room. Move that over here. So I get negative 10 over 12. 144 minus 125. I don't know. That's 119. Positive 114. And then what you're going to do is, of course, you're going to take negative 10 over 12, and you're going to multiply it by 114 over 119. That's taking the reciprocal of the bottom fraction. And then I see 12 goes on 144 12 times. It feels like I get negative 120 over 119 when I'm all done. So if I haven't made a careless mistake, that should be the answer. And then this next one, cosine 2 theta, you get to pick any of these. I don't know. Pick the middle one, just because. Pick the middle one. Now, depending which one you pick, your answer might be slightly different. But if you take the decimal approximation of either one of them, it will give you the exact same decimal answer. So I'll pick the one I circled right there. Cosine theta, again, was negative 12/3, excuse me, negative 12/13. Don't forget the square and subtract 1, 2 times 144 over 169. Okay, let's see. Well, nothing reduces here that I'm aware of. So I guess I'll multiply straight across. That would give me 288 minus, well, 169 over 169, and then 288 minus 169. And take my calculator. I don't remember that in my head. 119. Okay, so I get 119 over 169. Should be the answer for that. All right, flipping the page. So, same thing, wheel, don't know that. Have no idea. 15 degrees is not on the wheel. But if I used the identity that I saw in the front, and I go backwards, try to match that up. Okay, 2 sine cosine, right here, 2 sine cosine. Then it appears that I can rewrite that as 2 times sine of whatever the angle is. 2 times sine, that's 2 times sine. Let's see if I wrote that. I didn't write that right. It's sine of 2 times whatever the angle is, which is 15 degrees. Oh, that's a half. So apparently if I took, just to check it, took my calculator, and on the left-hand side, in degree mode, I did 2 sine 15 degrees and cosine 15 degrees, I'd better get 0.5, which I do. Hey, it worked. In like manner, you're going to end up finding one of the identities that looks like 2 cosine squared theta minus 1. 2 cosine squared theta minus 1. There it is right there, the one I used before. So that's the same thing as 2 cosine 2 theta. So I get to rewrite that as cosine 2 times whatever the theta is. Oh, and theta is pi over 8. Yeah, I know that answer. That's root 2 over 2. So you get some of those problems where you got to use it that way as well. This problem here, not doing any identities. Nope. If I gave you any problems on your homework that says verify the following identities, don't do them, because I'm not going to test you on them. You just have to, I don't know, believe that that actually does work, and because I'm not going to test you on them. Okay, 5.3. Let's see what else I got. Oh, half angles. So the last ones were double angles. These are called half angles. And notice tangent now has some choices. That looks messy. I'd probably pick one of those two if I had to. Up here, the reason why I have to consider the plus minus is because where does the original angle lie? And that would determine whether I picked the first, the positive or the negative in either one of these. Where does the original angle lie? So for instance, 15 degrees. That's in Q1. So I'm going to say pick positive square root. Like this one here, 155 degrees. Okay, what quadrant is 155 degrees? Hold on a second. Yeah, I'm going to backwards. I'm going to go backtrack just for a second here. Okay, I'm back. So think about it this way, a sine of 155 degrees, that's quadrant, isn't that Q2? Isn't that answer going to be, let's see, A smart trig class S. Sine's going to be positive in this, so you say pick positive square root. And I'll get to this one in a second too. So I'm going to use this one, and you'll know which one I checked off. I'm going to use that one, and I know I'm going to use the positive square root, not the negative, because of where the 15 degrees sits. So here we go. I'm going to go cosine. The idea is to create a fraction, so you have a 2 down here, so that you end up with 15 degrees. I need a 30 degrees there. So yeah, 30 divided by 2 is 15. So this is considered your alpha right there. 30 degrees right there is considered your alpha in the formula. So 30 degrees, I'll put 30 degrees in that part of the square root right now. And you need the positive answer. Square root, okay, 1 plus, that's root 3 over 2 divided by 2. And now we've got a crazy fraction, so simplify that. Common denominator 2. So that's 2 over 2 plus root 3 over 2 divided by 2. I need to push that together as 2 plus root 3 all over 2 divided by 2. Okay, that's the same as 2 plus root 3 all over 2 times. Now, so what you got to remember is take the denominator fraction and take the reciprocal and multiply it to the numerator fraction like that. And you got 2 plus root 3 all over 4, and then square root of 4 is 2. That's outside the radical, and the radical stays on the numerator. Ooh, what a mess. Did say it was going to be pretty. Now, if you're wondering, is that really the answer? That's called exact answer. If that's really the answer, then you can take the decimal approximation of this and take the decimal approximation of this, and they're supposed to be exactly the same. Exactly the same. Okay, B. Now, I'm going to pick one of the easy ones on this. I'll probably pick, let's pick the last one here. Pick the last one. It looks easier than this mess, because I'd have to figure out which sign I want to use. This one, you don't need that issue. So I am going to figure out what my alpha is. So I've got to do something here. So what do I need to do? I need to say, if you think about this, wouldn't you double this to get, wouldn't you double that? Wouldn't I need to double this, whatever this is? So double the angle, double that gives me 30, double 3 pi over 8 should give me, well, again, double that, that would be 2 times 3 is 6, 6 pi over 8. Oh, and that can be reduced to, what is that, 3, 2 goes in that, 3 pi over 4 divided by 2. And this is your alpha. That's your alpha. So here we go. We're going to use this one here. So I want sine of the alpha, which is 3 pi over 4, all over 1 minus cosine of 3 pi over 4. Sine 3 pi over 4 on the wheel. Okay, that gets me in quadrant number 2. That's positive root 2 over 2. 1 minus cosine of 3 pi over 4. That's negative root 2 over 2. So So root 2 over 2 divided by 1 plus root 2 over 2. Okay, keep going. Squeeze this in here, root 2 over 2. Okay, top and bottom by 2. Yeah, what a mess. I'm going to put print like this, and then that would be 2 over 2 plus root 2 over 2. Oh, I'm going to run out of room. Root 2 over 2. Now, if I push this together, that would be 2 plus root 2 all over 4. So if I multiply by the reciprocal instead of dividing, I'd have 4 here all over 2 plus root 2. Oh, what a mess. This is reducing. And it appears that I'm left with 2 root 2 all over this thing. Where am I going to put that? I'll put it in red over here. My final answer after I push the numerator together is 2 root 2 all over 2 plus root 2. So if I haven't made a careless mistake, should be the answer. And if I want to check it, put your calculator in radian mode here and see the decimal on both of them, and they're supposed to be the same thing. All right, this one here, I'll have to do it on a separate piece of paper. And I am looking for the separate piece of paper. I should have had that somewhere. Okay, let's see. Separate piece of paper. Rewrite this over again. Pick that formula right there. Now, because this is a quadrant 2, sign is positive in quadrant 2, so you put a plus. And then we have to figure out what the twice this is, because 155 is not on the angle, or not on the wheel. Sign, so just double that, because you're taking half of it, doubling it, which is 310, gets you the alpha. And this is your alpha right here. And then back up to here, 1 subtract. Okay, cosine of 310 degrees is what I'm looking at, all over 2. So 310 degrees, I'm going to look at my wheel. I've got that one here. 310. What? That's not on there. Maybe I did arithmetic mistake. Let's see if I did that. All right, doubling this. 155. Okay, well, fine. Let's do it this way. Is 310 divided by 2 155? It is. I can't do this problem. This is a bad problem. Because 310 is not on the wheel. It'd have to be something on the wheel, and I can't do it. This is a bad problem. Bad. I can't do it. Can't do this. Can't do this one. Well, there you go. But I'm giving you 2 examples that you can do, and the author should give you a couple more. Okay, flip it over. And finally, recognize that anything with identity we're not doing, so we're not doing that one. And I am going to do a couple of these. This one here is going to be helpful if you draw a triangle. So if I did that, draw a triangle like this. I'm in quadrant number 1, according to that. Here's my theta. Secant is negative 3 over 1. Now, secant is the reciprocal of cosine. So I'm thinking secant of theta is equal to -3/1. So cosine of theta is equal to -1/3. So a little easier for me to remember this because that's adjacent over a hypotenuse. So a hypotenuse has to be here. Adjacent has to be here. I've got my triangle in the wrong quadrant. Look at that. I just screwed up. This should be quadrant 2. That's quadrant 2. I just screwed up. So let's fix that. Makes more sense as well because watch. That negative sign had to go somewhere and there's no way it would, everything's positive in quadrant 1. So try this again. 1 here, 3 there. This has to be the negative. That has to be the negative. All right, now back over here. Sine of theta over 2. So the formula, I'm going to have to use the formula to do anything. And going back over here, here's your formula. 1 minus cosine alpha all over 2. And you have to decide plus or minus, plus or minus. So here's what you do. We don't know what the original angle was to decide that. So this is just half of that angle is the original angle. Where would the original angle actually be sitting? If I knew the theta, which is more than the original angle, think about doubling the original angle. If I doubled this angle, what quadrant would I be in over here if I doubled this angle? You could think of it like, gosh, what's an angle that's in here? Like 170 degrees. If I doubled 170 degrees, wouldn't the original angle be over here? Yes, 340. What about 95? If I doubled 95 degrees, 95 degrees, would the original angle be in quadrant 4 or quadrant 1? What's doubling this angle 95 would be what 100 if I said 95 degrees and I doubled that, that's 190 degrees. So I would be over in quadrant number 2. Quadrant number 2. 1 second again. Okay, back at it. So let's go back over this again. I need to bust this thing up and find the result here. What quadrant am I in? There's 2. So the answer that I need should be quadrant 2. For a sine, I should end up being positive. So I'm going to take a positive answer. Okay, here we go. As simple as that. Square root 1 minus, okay, cosine theta from here, there it is. I didn't even need the triangle. I didn't even need it. Cosine theta is equal to -1/3, 1 minus -1/3 all over 2, square root 1 plus 1/3 all over 2, square root, that's 3/3, that's 4/3 all over 2, square root 4/3 times 1/2 square root. Gosh, the 2 and the 4 goes away, so that's 2/3. And that's it, square root of 2/3. That works. And then in like manner, I'll just do this one because I don't have enough room for the cosine up there. It's all similar in terms of the process, but I need to pick one of those tangents. I'll pick this one just to be different. 1 minus cosine, and we're a theta. So this is 1 minus cosine theta over sine theta. Make sure I wrote that down right. Yep. So 1 minus, okay, cosine theta was -1/3. Okay, now sine theta. Now I'm going to have to figure out back up here what the y value is. I have to know what this y value is. So now I have to use the Pythagorean formula. And the Pythagorean formula says y squared plus a negative 1 squared is equal to 3 squared. Y squared is equal to, that's 9 subtract 1. Y squared is equal to 8. So y is equal to the square root of 8. So it's plus or minus. Gosh, y is up here, so it's got to be positive root 8. Y is equal to positive root 8, which is 2 root 2. So right here, sine of theta is root 8 or 2 root 2, root 8. Going over here, again, I have 1 plus a third all over root 8. That's 3/3, that's 4/3 divided by root 8 or times 1 over root 8, which should be 4 over 3 root 8 is a version of the answer. 4 over 3 root 8 is the version of the answer. So, shorter section. Sorry for the interruptions a few times to have to stop and pause it. But that's life right now in a garage with things like a wash machine. All right. Hope you have a great day, and we'll talk to you in class.